Okay, so I've shown you how to derive the unit circle, starting with just what the unit circle is. I'm not going to have you memorize the unit circle, but I will expect you to be able to take a unit circle and figure out what the trig functions are for the angles that are appropriate on the unit circle. So there's two parts. There's the angle part and this is the value part. So what you have here is the angles. And so these are, remember, you take 360 degrees, break it up into 4 parts. So you got 90, 180, 270, 360. Then you break each one of the quadrants in 2, and that's 45, 135, 225, 315. And then you can break it up into thirds. So you have 30 degrees, 60 degrees, then you get to 90 degrees. And so you go by increments of 30. And those increments of 30 also include the coordinate axes. So what you see are the angle numbers. And then you see the corresponding radian values. So 30 degrees is pi over 6, 150 degrees is 5 pi over 6, 300 degrees is 5 pi over 3, etc., etc. So if I give you an angle between 100 and 0 and 360, or 0 and 2 pi radians, then you should be able to go here and figure out which one of these intersections of the ray and the circle is the particular angle. Okay, now associated with these intersections of the unit circle, with these rays that define the second side of the angle, there are coordinates. You have an x and y coordinates. So, at the intersection of the unit circle and the coordinate axis, we have 90 degrees and pi over 2, and the coordinate here is the x coordinate is 0, so 0, 1. Say 180 degrees is -1, 0, and those coordinates correspond to the values for the cosine and sine respectively. So another handout that you'll need to print out is the angles. So here are the angles. Well, here are the trig values. So let's just put this on one screen and look at what we have. So this point, which corresponds with 0 or 360 degrees, or 0 radians and 2 pi radians, the coordinates are 1, 0. X is 1, y is 0, and the key thing here is that the x coordinate is the cosine of the angle. So the x coordinate is 1, so the cosine of 0 is 1, and the sine is the y coordinate. The sine of 0 is 0. And you can do that, and I've already gotten them written in here. We're going to write them in for the third and fourth quadrants here in a second. But for the first and second quadrants, you can see that, if I take this point, I can go over here and get the y coordinate, and I can go down here and get the x coordinate. So the y coordinate is the easy one because it bisects this line, this radius from here to this point pi over 2, or 90 degrees. So we know that's a half. So the y coordinate is a half, and so the x coordinate has to be the other thing, which is the square root of 3 over 2. And if you take the square root of 3 over 2, just plug that in your calculator, you'll get 0.866, which is pretty close to 1, and this obviously is much closer to 1 than this is. So that's kind of another way that you can use the unit circle. Okay, but what I'm expecting you to do is just to say, oh, okay, this ray here with respect to the x-axis defines the angle, and the angle is, you go to the other sheet, which is pi over 6. The cosine of pi over 6 is the square root of 3 over 2. The sine of pi over 6 is a half. You just use those coordinates to figure out what the cosine and sine. Now you're used to a lot of times doing sine and cosine, so this is kind of opposite. You have to remember the first coordinate is the cosine, the second coordinate is the sine. So you go to the next ray, which defines 45 degrees or pi over 4 radians. And if I went over to here and I went down to here, you can see the value, the x and y value is greater than 0.5. 0.5 would be right there, so it's greater than 0.5, and that they have the same value because of symmetry. So we know, if we didn't even know this, we kind of deduce what the value would be. So the other trig function value is the square root of 2 over 2, and because they're the same here at 45 degrees, the cosine of 45 degrees is square root of 2 over 2, the sine of 45 degrees is the square root of 2 over 2. If you plug those in your calculator, the decimals are 0.707. They're in the first quadrant, so they're both positive. Then you get to the next ray around the unit circle, which is 60 degrees, or pi over 3. And again, if I drew a line straight down, I'd get the x-coordinate, and that bisects this x-axis. So it's got to be 0.5 or half. So the cosine, the x-coordinate is a half. The y-coordinate is the one close to 1, which is the square root of 3 over 2. So x is a half. Y is the square root of 3 over 2. Cosine of theta is a half. The sine of theta is the square root of 3 over 2. Okay. Now when you come over here, you've got these three additional values, and you can look those up on the other sheet. But you can see that, this ray and this ray have the same y-coordinate. They have the same x value, except this one's positive and this one's negative. So you can see all I have to do is copy these two values over here and make this one negative, that one positive, whereas the y-coordinates are both positive. And you see that same thing happen here. If we go here at 45 degrees, this angle, which is 135 degrees, has the same y value of square root of 3 over 2. They're both positive y values. The x value is negative compared to this one. And finally, this one, they have the same x and y values, except the x value here is negative versus the x value here is positive. So if I said, what's the cosine of this angle, 135 degrees, you'd say the cosine is negative the square root of 2 over 2, and the sine is positive the square root of 2 over 2. So we're going to do the same thing here, coming down. So again, this point here is symmetric with this point around the negative x-axis. It has the same x value, so it's going to have negative the square root of 3 over 2 is the x value. But here the y value goes from positive to negative, so it becomes negative 1/2 instead of positive 1/2. And you'll see the same thing happening here. And we know in the third quadrant they're both negative. So all of these have negatives. Then this one's square root of 3 over 2 is x, so this one has to be 1/2 is x. This one has to be square root of 2 over 3 is x. Okay, then you get to the fourth quadrant. In the fourth quadrant, the x value is positive and the y value is negative. So these two mirror, these are reflected across the negative y-axis. So they're going to have the same values. The x value is now positive, but the y value is still negative. Here, the same thing. The x value is positive. The y value is negative. And finally, the same thing here. So we're going over here to find the values. So the x value is positive. The y value is negative. And then you come all the way back around. You start in the first quadrant. They're all positive again. So let's put this on one page here. So again, for a unit circle, the x-coordinate is the cosine of the angle. y-coordinate is the sine at the angle. So you'll be able to use this to figure out what the trig values are. Now these are all in, these are the in radical form, square roots. Now what I've got over here is I've done it in terms of radians, but instead of doing it, pi radians, I have 3.14159. So I've got the decimal equivalent. So these are the angles in radians, but not as a multiple of pi, but just as the decimals. So you can see what kind of values you get. So if you had an angle that was, say, 4.5 radians, you'd see that that goes in the third quadrant. If you had an angle of 5.5, you'd see that it would be somewhere about here, and it would be in the fourth quadrant. And the corresponding values would be the same as we have over here. One difference is that you could use the fact that the square root of 2 over 2 decimal value is 0.707. Half obviously is 0.5, and the square root of 3 over 2 is 0.866. So those are, you could show this coordinate, say here, the x-coordinate is the square root of 3 over 2, so it's 0.866, comma, the y value is a half, so you'd have 0.5. So instead of having the square root of 3 over 2, comma, 1/2, you could have 0.866, comma, 0.5. That's the decimal equivalent of that. Okay. Now the last thing is you can get the other trig functions by doing this, but let's review here. So the sine of theta is the y-coordinate. The cosine of theta is the x-coordinate. Okay, we had that earlier down here. X equals cosine theta, y equals sine theta. You can also find the other trig functions. So the tangent of theta is y over x. So you take the ratio of those two numbers, except x cannot equal 0, because if you do that, it becomes undefined. And that happens at when the cosine goes to 0, which is at 90 and 100 or 270. And then you have the other ones. So you have the reciprocal of the sine is the cosecant of theta, which is 1 over y. Y cannot equal 0. You have the secant of theta, which is 1 over the cosine. So you get 1 over x, except x cannot equal 0. And finally, you get the cotangent of theta is equal to x over y, but y cannot equal 0. Here we couldn't let x equal 0. Here we can't let y equal 0. And they're never 0 the same. You never get an indeterminate result. Okay, so that's that. And I'm going to do a separate video of just going through some examples of the kind of problems you have in this section, and then you can work some on your own.